Good morning, ladies and gentlemen. Welcome to the second day of Second International Symposium of Earth, Energy, Environmental Science, and Sustainable Development 2021. My name is Adinda Mayanti from School of Environmental Science, Universitas Indonesia, and I will be your Master of Ceremony for this year's event. This event is aimed to advance scientific knowledge and understanding of the theoretical, methodological, and practical aspect of environmental science and sustainable development, featuring world-class speakers and editors worldwide, such as from USA, United Kingdom, Nigeria, Bulgaria, Ukraine, and Indonesia, to exchange our knowledge, exchange, and learning from various backgrounds all around the world. This year's International Symposium is organized by Journal of Environmental Science and Sustainable Development, School of Environmental Science, Universitas Indonesia, and supported by PT Riau Andalam Pulp and Paper, April Group, Induk Koperasi Kepolisian Negara Republik Indonesia Inkopol, PT Arlindo Grafimedia, PT Unilever Indonesia Terbuka, Bank Rakyat Indonesia, PT Penjaminan Infrastruktur Indonesia, PT Mirror Soputan Mining, PT Merdeka Copper Gold, and Green Era Consulting. Before we start our day, please kindly listen to the national anthem of Republic of Indonesia, followed with Universitas Indonesia hymn performed by Paragita Universitas Indonesia. next session is special talk session to discuss about this year's special issues, which is COVID-19 and community management with three of our speakers. Professor M. Panayotova from Department of Chemistry, University of Mining and Geology, Bulgaria. Professor Rotimi Williams Olantuji, PhD, ARPA, MNPR from School of Communication, Lagos State University, Nigeria. And Professor Svetlana Drobiasko from Open International University of Human Development, Kiev, Ukraine. To guide us through this session, we would like to introduce Ms. Dia Fitri Ekarini as our moderator for today. Dia Fitri Ekarini is currently an active student of Master Program in Environmental Science of School Environmental Science, Universitas Indonesia. Her main interests and concerns are related to biodiversity, wildlife conservation, and community engagement. Fitri had a Bachelor of Science degree in Biology from Faculty of Biology Gadjah Mada University. Since 2014 until now, Fitri has worked as a wildlife conservationist in various projects and organizations in Indonesia. Ms. Fitri, this session is yours.
Okay, thank you very much, Ms. Afifa, for your kind introduction. Good morning, ladies and gentlemen. My name is Fitri, and I will be the moderator for today's special session. For this session, we have three international speakers. They are Professor Rotimi Williams Olatunji, Professor Svetlana Drobiasko, and Professor Marinela Panayotova. After all the speakers present their presentation, we'll have a brief Q&A session. I would also like to remind the audiences that there are prizes for active audience members. So please pay attention and ask questions. Now, I would like to invite Professor Rotimi Williams Olatunji to present the presentation as our first speaker. Professor Olatunji is a professor in public relations and advertising who have taught many courses across the different areas of specialization in the School of Communication, Lagos State University, Nigeria at the various levels, ranging from the undergraduate levels until postgraduate levels. Professor Olatunji's specialization is including in health communication, advertising, public relations, and political communication study. Professor Olatunji, now the time and screen is yours.
Good day, the global community, and welcome to the second International Symposium of Health, Energy, Environmental Science, and Sustainable Development, taking place 25th to 26th September 2021 in Indonesia. I'm happy to be invited as a keynote speaker. I was part of the participants at the first International Symposium last year. That was 2020. And today, I'll be speaking on waste management and sustainable development in sub-Saharan Africa, the case of Lagos, Nigeria. My name is Rotimi Williams Olatunji, Professor of Public Relations and Advertising, School of Communication, Lagos State University, Nigeria. And Lagos State University, Nigeria was established in 1983, and as at 2020, the Times Higher Educational Ranking ranked Lagos as second best university in Nigeria. The current ranking puts Lagos as number 5 in Nigeria, and now the best state-owned university in Nigeria. We have a Center for Environment and Sustainable Development. I am a member of that center, but I'm a professor in the School of Communication. Now let's look at the topic within the context of the sub-Saharan Africa. The topic again is waste management and sustainable development in sub-Saharan Africa, the case of Lagos State, Nigeria. I want to thank those who invited me. Now, the context, the African continent. The African continent is the second largest continent in the world, next to Asia, and it is crossed by both the Tropic of Cancer and the Tropic of Capricorn, and is located on the equator, 23 degrees south of the equator. The African continent has an estimated population of 1.3 billion as at September 16, 2021. And in the African continent, there are 54 countries, out of which 46 of these are in the sub-Saharan Africa. Nigeria, where I speak from and where my topic focuses, has a population of over 200 million people, and it is has the highest population on the African continent, next to Ethiopia. Now, I'll be talking about sustainable waste development in Lagos State, Nigeria. Let's look at the context of the Lagos city. Lagos State is one of the 36 states of the Federal Republic of Nigeria, and it is a coastal state, and Lagos is a coastal city with a population of over 20 million people who live and work in the city. The volume of waste generated in Lagos State on a daily basis is like 1 million metric tons per day. And previously, most of these wastes are mostly sandfilled. However, unsustainable waste management in Lagos State, Nigeria, brings about huge financial loss, environmental and earth damages, with the uncontrolled emission of greenhouse gas such as the methane and other forms of gases that tend to affect the environment negatively. And because of that, the Lagos State government has what we now call the Lagos State Waste Management Authority. Lagos State Waste Management Authority was established initially in 1977, preparatory to the popular Festac 77. That was the Festival of Arts and Culture that was held in Africa, with Nigeria playing the host. And Lagos was the city of the cultural festival at the time. And there was so much waste that the government decided to clean up the city. And so the Lagos State government established the Waste Management Authority in 1977. Now, what is waste? Is waste actually waste? Or can we have anything positive about waste? Waste ordinarily is everything that no longer has a value. It has little or no use or purpose and needs to be discarded. You will see that if we stretch this definition further, there is actually nothing that can be wasted, because everything that anybody may dispose may be useful to somebody else. So the above definition considers waste as a natural consequence of human activities. Every human being generates waste. Every living thing generates waste. And therefore, waste should not be seen as a burden onto society, but as an essential part of life. Now, with the shift in attitude globally, our understanding of waste has been changing over time, particularly with the global burden of global warming and all the associated environmental challenges of flooding, of gas emission, of all of those disasters that occur. We need to have a second look at waste that does not see waste as valueless, but waste as valuable and critical assets to the society. Now, let's look at a tale of two cities. On the left side of the screen, you see a city that is congested. That's Lagos for you. It's a street on Lagos Island with hardly a space for human beings to move. but humans and vehicles compete for space. And now, on the second hand, is a street in Ikoyi, one of the eyebrow area of Lagos State, where the high class in society live. But you can see the difference in the two cities is the ability to manage the waste and manage the environment that makes all the difference. And so, the metaphor of the bee, honey, is what I'm starting with to illustrate the value of waste in society. Bees need more different kinds of food that are collected from the nectar, particularly the juicy part of the flower, and then they convert it through their numerous processes into what human beings now consume as honey. So to the bee, it looks as if it was a waste, but to us human beings, it is honey and a most prized and priceless nutritional food that keeps the human population going. So eventually, the waste product of the bee is what humans lick as honey. Ideally, nothing is therefore wasted in nature. It is the unsustainable human practices that create waste. Now, let's look at categories of waste that we have in the society, particularly in Lagos State. There can be solid waste, animal products, biodegradable waste, biomedical waste, chemical waste, construction waste, electronic waste, gaseous waste, commercial waste, and the list is endless. So there's a table, there's a chart here showing the different categories of waste that we have in Lagos State. This was generated by the Lagos State Waste Management Authority, with vegetable waste constituting 45%, paper waste 10%, glass, plastics, metals, textiles, in that order. You can see that part of the challenges we have in Africa, particularly in Nigeria, is that the food culture tends to generate more waste than other forms of waste. Not only that, industrial waste, because Lagos is the most industrialized city in Nigeria, and therefore it constitutes the highest form of waste. Particularly, you see now the e-waste, electronic waste, that are also rising in the horizon. So, how do we now turn waste to wealth? And that's where we come with the case of the Lagos State Waste Management Authority. Now, you can see on this screen that there are different processes that we need to undergo to convert waste to wealth. But let us talk a little bit of what the Lagos State Waste Management Authority has been doing. They have a lot of waste to contend with, particularly the food waste that are rampant in the society. So the Lagos State Waste Management Authority developed plans with manufacturers in the food and beverages sector to begin to convert the food waste into wealth. There's also the issue of voluntary waste reduction practices across all sectors that are going on. And then, but mostly the collection of waste from domestic, industrial, hospital is directly under the Lagos State Waste Management Authority. But because of the huge population of the country, of Lagos State and Lagos City, it has been so challenging for the Lagos State Waste Management Authority to effectively handle prevention, reduction, reuse, recycling, recovery, and the disposal of waste, which should just be the least consideration in terms of waste management. So how then do we turn waste to wealth? For example, one of the most prominent waste is what we call the plastic bottle, the nylon bag, and so on and so forth. So on the right side of my screen, you can see a lot of paper, nylon bags, and plastic bottles that are non-degradable. So previously, the attempt was that we would just dump this in dump sites and so on and so forth. But today, there have been opportunities created by government and the private sector to begin to convert this plastic waste into resource materials of different value. And so the plastic waste exchange is now taking place even in schools where students are rewarded for bringing waste, plastic waste and all of that for collection. There's also the provision of guarantees in the banks for investors who are in the habit of recycling waste. And then the Lagos State Waste Management Authority distributes waste containers across the state so that they can collect waste materials of different types and then sort it out later and dispose it accordingly, either for reuse or for recycling. And so you can see on my screen here a plant in the Lagos State that is trying to convert the plastic waste into wealth. So you see that this is taking place in some parts of the state, and therefore, but the percentage of conversion is relatively low, with 12% conversion rate currently happening in the economy. But the goal of the Lagos State Waste Management Authority is what we call the circular economy, and we are going to see, listen to a video clip on the circular economy in Lagos State now.
Look around you. There is waste everywhere you turn. From PET bottles to paper, we are surrounded by waste from products that we consume.
The current thinking about product life cycle is fundamentally linear. Products are produced from raw materials, we consume them, and they become waste.
Most times, this waste is not properly disposed. The ones that end up in landfills like these are unsorted. Some are burnt, polluting the air and causing danger to our health and the environment. Others, especially plastics, will take hundreds of years to degrade. But one Nigerian is changing the narrative. Lolade Oresonwo runs a UK company leading an effort to achieve zero waste at landfills in Nigeria. In the last 6 years, this facility has been putting back 1 million kilograms of waste into the production economy every month. Women form 70% of its workforce.
It's not just creating wealth, it's actually solving an environmental and a health problem. If you recycle the waste, then you don't have problem with, leachates, with, groundwater contamination. So it's a no-brainer that they need to start taking seriously.
All over the world, this linear product life cycle is no longer sustainable. Products are now designed in such a way that they are cycled and reused, which means that your waste is a raw material for another product.
The World Economic Forum estimates this new economy to be worth $4.5 trillion. But the Nigerian consumer market today shows little signs of maximizing this opportunity.
It is an absolutely huge business. As we stand now, we're creating jobs for at least 3,000 people. That is one company. Now imagine the amount of cottage industries that come out of this place. What waste you're looking at over there? There's plastic, there's paper, there's metal, there is aluminum cans, ferrous and non-ferrous metals in it. And there is earth in it, earth that can be reconverted to compost. Why are we buying inorganic fertilizers when we can make organic fertilizers from our waste? What you are having is an end-to-end process that you don't even see waste. That is the idea of the zero waste.
In 2019, Nigeria, in partnership with Global Environment Facility and the United Nations Environment, launched a $15 million initiative to recycle electronic waste. While this sits within the circular economy approach for electronics sector in Nigeria, there is no clear policy on whether such an effort will be extended to other sectors of the economy.
What are the benefits, key benefits of sustainable waste management? By and large, waste management has high economic value. It contributes to the growth of the economy, and not only that, it also creates employment. It creates a friendly environment, and it brings about total well-being of man. And so if we can manage our waste successfully in this part of the world, then we are also creating quality life for the citizens and for the global community by extension. Again, let's look at another video on how the e-waste, particularly waste created through computer and so on, has been managed in Lagos State so that we can have a reduction of a crisis in the environment as well as add to the economy of the country.
According to the United Nations Environment Programme, over 500,000 tons of discarded appliances are processed in the country annually. In most cases, when the e-waste end up here, residents who are out to make some quick cash scavenge the waste with their bare hands at the risk of their health. Up to 100,000 people work in the informal e-waste sector in Nigeria. I want to meet Usman Sani, who has been picking e-waste off dump sites for 5 years.
How much money do you make in a day?
4,000.
4,000 naira. That's about $11.
Yeah, yes.
So who do you sell all this to?
Get one customer where you can buy for me.
A customer comes here
Yes.
and buys them from you.
Yes.
Even though this may not look like a very big business for scavengers like Usman, there are Nigerians who have made a lot of profits from electronic waste.
Isaac Egu is an e-waste merchant who has been in the business for the last 15 years. It depends on scavengers like Usman for his supplies.
So how big is your business? By this I mean, how many people do you have in your employ?
I have like 10 people working with me, and they work from Monday to Friday.
So on an average in a month, how much profit do you make in this business?
I make like 200,000.
That is more than $500, right?
Yeah, that is it.
It looks like the country is gradually seeing the money side of the e-waste. In June, the Nigerian government, the Global Environment Facility, and the United Nations Environment Programme announced a $15 million initiative to kick off a circular e-waste system in Nigeria.
According to studies corroborated by the United Nations Environment Programme, there is 100 times more gold in a ton of e-waste than a ton of gold ore. It's not just about gold. E-waste are huge sources of iron, copper, platinum, aluminium. I've come to see how this recycling company in Lagos is helping to turn this e-waste to wealth.
Ifeanyi Ochonogo, who runs this recycling facility in Lagos, has been in the business since 2013.
How much waste does this facility handle every month?
We're approaching a ton every month. Things are looking up because the legislation has come out and the enforcement of that legislation is clear as of this year.
What kind of precious metals do you mine for in this e-waste?
You have various amount of precious metals, various kinds of precious metals, from gold. You have other precious materials such as neodymium. That's a rare earth material that needs to be used to manufacture your hard drives.
How do you make money from all this?
A lot of people need their confidential data managed, from the World Bank to Nigerian government and NPC, whoever you can think of. They need their confidential data secured. That's on a monthly basis. So this is something that I'm glad that the whole of the country is becoming more awake towards and practical as well.
With fast technological advancement making many of these electronics obsolete, chances are they would end up in a dump site. How much do people know about the economic potential in e-waste, along with the dangers associated with continuous exposure to such waste? There is no better place to find out than Nigeria's own Silicon Valley, known as the Computer Village in Lagos. Maduka Anthony has been selling and repairing old electronics but has no idea of how big the business of unusable electronics is.
How do you dispose of your electronic waste?
We don't have any specific or a defined means of disposing those electronic wastes. The only people we dispose it through is those, will I call them cat pushers. They normally flog around asking for the scraps. You know, those are them that we are unable to fix and get it to working again. We sell it off to them at peanuts.
Now, are you also aware that this e-waste can be mined for precious metals like gold, like silver, like copper, like platinum?
Not really. I'm not much aware about it. Apart from some of those cat pushers, because most of the time after gathering this, they have some dump ground. After gathering those stuffs, you see them in the evening extracting some vital components from it.
While many developed countries are shipping their e-waste to less developed countries, some business-minded people in countries like Nigeria import the e-waste for its economic value. Kunle Falai, BBC, Lagos, Nigeria.
So ultimately, our goal is to have a cleaner Lagos and also to have a cleaner global environment. However, there are certain challenges that mitigate against effective waste management in Lagos State as in other African countries. One of them is the control that the government hold, not having the right enabling environment. There's also the issue of the growing population, not to talk about the paucity of funds created by the economic crisis in the system, lack of access to certain equipment or capital to enhance quality environment. And so these are some of the challenges, and it is believed that if we effectively provide policy and support, we can effectively manage waste. For us at the communications end, we need to continue to create more awareness on effective waste management, the need for waste to wealth, and effective awareness on how to prevent, how to reduce, how to effectively manage our waste in our environment. Development without communication can hardly be possible. And that's why in development communication, we need to tie government activities in waste management, environmental sustainability with the issue of adequate awareness campaigns and communication packages that will give support to government activities to change the attitude of the people, to change knowledge, to give more knowledge, and to transform the society through effective and positive practices on the environment. I want to thank you for listening. Once again, my name is Rotimi Williams Olatunji, Professor of Public Relations and Advertising, School of Communication, the Lagos State University, Nigeria. Thank you.
Thank you very much, Professor Olatunji, for your insightful presentation. To highlight Professor Olatunji's presentations regarding the sustainable waste management in Lagos, Nigeria, I noted that there is a sustainable practice that is currently going on in Nigeria in a form of a program that is carried out by Lagos State Waste Management Authority to turning waste to wealth. This is a good example of the circular economy practices in sustainable waste management, where we can turn waste, which seems invaluable at first, into wealth. Okay, now let's move to our next speaker, and I would like to introduce Dr. Professor Svetlana Drobiasko. Dr. Professor Drobiasko is a professor in economic sciences from Open International University of Human Development, Ukraine, Kyiv, Ukraine. Professor Drobiasko also affiliates to the European Academy of Sciences, London, United Kingdom. Professor Drobiasko's specialization is including in business, management and accounting economics, and also econometrics and finance study. Professor Drobiasko, now the time and screen is yours.
Dear colleagues, a report on the impact of sustainable development of space activities on the Earth ecology is presented to your attention. The article is devoted to the problems of space debris in the age of the new space. The authors of the research: Svetlana Drobiasko, Doctor of Economic Sciences, Professor, and Tetyana Hilerme, Doctor of Economic Sciences, Associate Professor. In the age of new space, mankind faces the global problem of orbit space constraint. Sustainable development of space activities will be possible only when space users implement technologies and practices suitable to avoid the accumulation of objects in orbit. Man-made debris in orbital space has reached catastrophic proportions. This has a negative impact on the Earth's ecology, leading to increased steps to transform a planet that is not suitable for life. Procedures for the formation of alternative scenarios and solving forecasting problems necessitate the use of expert assessment methods, which are mainly methods of SWOT analysis, Delphi methods, and morphological analysis. Cognitive modeling is involved for building of scenarios concerning the selected alternatives, which gives the chance, based on the proposed mathematical methods, with practical certainty to receive a substantiated scenario for decision making. Phases of the life cycle of rocket and space equipment in accordance with European standards. Mission analysis, needs definition, feasibility, preliminary design, detailed design, qualification and production, operation, utilization. The Ukrainian government plans to become a member of the European Space Agency, which draw increased attention to taking into account these phases of the life cycle of rocket and space equipment. According to the results of SWOT analysis, it is found that the weak side and threat to the activities of the aerospace industry is the insufficient funding of implemented projects and inefficient distribution of finances between its components, science and production. It should be noted that the aerospace industry is a critical infrastructure. The development of the aerospace industry is a component of national security. The application of blockchain technology in space activities can be carried out in the following areas: financing of space startups and asset creation, tokenization of space assets not for investment purposes, tokenization of requirements for data of remote sensing of the Earth, information management on the full cycle of a space mission, secure satellite communication, creation of virtual security zones of different levels, public procurement in the space industry, ensuring cybersecurity of space assets through supply management. According to the carried out content analysis, it is possible to build a classification of environmental risks arising from space activities. 4 groups are identified. The problem of space debris is gradually becoming increasingly important for the future use of outer space. Many simulations based on evolved modeling assume that the number of objects in orbit will increase non-linearly, even if no new objects are added to space due to collisions caused by existing debris. Ukrainian national legislation in the field of space activities is at the stage of harmonization with international space agencies. There are still many insufficiently substantiated items: improvement of the technical regulations for space activities, the procedure for liability insurance for damage caused to a space object, as the relevant insurance contract must be one of the documents required to obtain a permit to fulfill the international obligation of the state to be responsible for any national space activities. Standards, guidelines of international organizations in the field of space sustainability. The maximum service life of the equipment in orbit at an altitude of up to 2,000 km should not exceed 25 years, after which it must be disposed of. Compliance of the technological capabilities of the platform, the extent to which onboard systems allow autonomous maneuvers to divert from orbit, transition to another orbit without interference from the Earth. Criteria for determining the service life of rocket and space equipment. Achieving a 90% probability of successful diversion of used satellites and analysis of the operation of large satellite groups, etc. The specifics of the proposed model is that the data subject to analysis have both qualitative and quantitative characteristics. The advantage of the model is the compactness of development due to the use of one platform and the efficiency of use due to the absence of the need to reload data into a specialized system. The main benefits from the introduction of Agile management according to the results of the Boston Consulting Group study are: cost reduction by 25–35%, improvement of product and service quality by 20%, acceleration of creation of new products and services by 100–200%. In the 21st century, the concept of clean space has emerged at the global partnership level. This initiative has three directions: eco-design, design of projects to address the impact of space debris on the environment; CleanSat, design of measures to reduce the formation of space debris; E.Deorbit, removal of large space debris from orbit. The graphic interpretation of components comparison of SWOT analysis of the rocket and space industry development is built. It is found that the weak side and threat to the activities of the aerospace industry is the insufficient funding of implemented projects and inefficient distribution of finances between its components, science and production. It is proposed to use the blockchain technology as an effective tool for cybersecurity of space objects. Possibilities of Agile management as overcoming barriers of introduction of innovative decisions in space activity are considered. The ecological risks from space activities that affect the Earth's ecology are analyzed. It is proven that the prevention of serious environmental consequences and minimization of the negative impact of the above threats require the introduction of environmental management systems in the system of space activities. Thanks for watching.
Okay. Thank you very much, Professor Svetlana Drobiasko, for your insightful presentation. From Professor Drobiasko's presentation, we can know that actually and currently, the mankind faces the global problem of orbit space constraint. Besides that, the man-made debris in orbital space has reached catastrophic proportions. We need to address this problem by implementing sustainable development approach to realize the concept of clean space and minimize the ecological risks from space activities. And last but not least, our speaker for this session is Professor Marinela Panayotova. I will briefly introduce Professor Marinela Panayotova. Professor Panayotova is a professor in minerals processing and recycling, and also the head of Department of Chemistry, University of Mining and Geology, Zain Ivan Rilsky, Sofia, Bulgaria. Professor Panayotova's specialization is including in mineral processing, physical chemistry, environmental protection, and water treatment study. Now, Professor Panayotova, the time and screen is yours.
Dear colleagues, I would like to thank the organizers for the possibility given to me to talk at this very interesting and useful event. As you can see, my presentation concerns mining and mineral processing waste and sustainable development. Metallic and non-metallic ores and industrial minerals are considered. Oil and gas are excluded from the talk due to the limited time. Mankind needs metals both for the development of state-of-the-art technologies and for our daily lives. The creation and use of new energy sources, study of space, cars of the future, communications, all of them require metals. The protection of our homes, transport infrastructure also need metals. Construction transport also need industrial and construction minerals. In addition, our economy is still dependent on energy from coal, and we shall need more and more, both for well-established and future technologies. The availability of metals and non-metals is impossible without mining and processing industry. Cessation of this type of activity is an illusion, at least for the foreseeable future. Substitution, recycling and usage efficiency improvements will not be enough on their own. The demand for all raw materials will rise, and the mining and mineral processing activities will continue to be the major source of raw materials in future. Humankind has no choice but to try to carry out these activities in the most sustainable way, with possible minimum energy and water use, with maximum protection of the environment and maximum extraction and utilization of all components of the materials excavated from the earth. The latter also means waste-free technology. However, these activities generate extractive waste. Extractive waste is waste resulting from the prospecting, extraction, treatment and storage of mineral resources and the working of quarries. Extractive waste may be solid waste such as waste rock, contaminated, overburden, smelter waste, solids from physical beneficiation and separation processes, dry flotation tailings, as well as waste from industrial minerals, cutting and sewing, waste sand, etc. Slurries, mainly flotation tailings, waste effluents, main drainage, especially acid mine drainage, also processing water. Amounts and type of waste vary strongly across countries depending on the several factors, including extracted mineral, geological conditions, mining and processing techniques applied. A residual to product ratio can be defined which reflects the relative amount of residues generated during the extraction process in order to extract 1 unit of mineral product. Typically, for surface extraction of base metal bearing ores, this ratio varies from 2:1 to 8:1. Usually, this ratio will vary significantly over the time and life of the mine. In underground extraction, this ratio will be usually less than 0.5 to 1. The relative amount of extractive residue generated during mineral processing is closely linked to the type of mineral resources processed, the ore grade, and the technology used. This ratio ranges from 1 to 1 for extraction of alumina from bauxite through 500 to 1 for nickel and surpasses 900,000 to 1 in the case of gold and platinum gold metals. The total amount of extractive residues generated can be defined as the sum of all the extractive residues generated during the different extractive processes. Key issues related to extractive mining and mineral processing waste can be classified as shown here: safety and stability. Measures have to be taken to confine and contain the extractive waste in the area designed for that purpose and to ensure the structural stability of the extractive waste and the confining structure, dam or heap. Eventual collapse of any type of extractive waste facilities can have short-term and long-term effects. Typical short-term consequences might include dangerous flow slides, release of hazardous substances, flooding, crushing and destruction, cut off infrastructure, poisoning. Potential long-term effects might include metal accumulation in plants and animals, contamination of soil, contamination of groundwater, loss of animal life, adverse effect on human health. Non-inert extractive waste might undergo significant physical, chemical or biological transformations which in turn might have adverse effects on the environment and human health. Examples include formation of acid rock drainage or neutral rock drainage, leaching of metals which might pose a risk of soil, water and groundwater contamination, migration of pollutants from the extractive waste, for example, cyanides contained in waste produced during the gold extraction, spontaneous combustion in the coal and lignite or metalliferous ores extractive industries. Emissions to water, soil and air can be particles. The main examples of such emissions are suspended solids, suspended particles, air particles PM10 and 2.5, suspended particles of hydrocarbon, oils and grease in water, dissolved substances. Sources of emissions of dissolved substances are acid rock drainage or neutral rock drainage. The acid drainage can leach metals and metalloids from surrounding rocks. The key pollutants in emissions are dissolved metals and metalloids, salt and anions such as sulfates, chlorides or bromides, alkaline and alkali earth metals, acidity in the case of acid drainage. The wastewater may contain chemical residues and dangerous substances used for the mineral processing such as nitrates and nitrogen-bearing compounds from explosives, cyanides used in gold extraction, xanthates and other organic pollutants used in fraud flotation, residues of caustic soda from the Bayer process. Greenhouse gas emissions, volatile organic compounds, etc., as well as combustion products such as nitrogen and sulfur oxides resulting from the management of extractive waste can be released. Other environmental and social issues include odorant noise, visual impact and land use, usage of water and consumption of reagents, vibration and induced seismicity, biodiversity loss, etc. Some illustrative data for the pollutants. Sustainable development is development that meets the needs of the present generations without compromising the ability of future generations to meet their own needs. To achieve a sustainable development, it is crucial to harmonize three core elements: economic growth, social inclusion, and environmental protection. When sustainable mining and mineral processing is considered, all above mentioned key issues related to mining and mineral processing waste have to be considered. However, due to our limited time, I shall outline briefly only those related to solid waste and water handling. In both cases, simultaneous implementation of both legislative and technological measures is needed. Some references to legislative measures related to sustainable management of mining and mineral processing waste are presented in this slide. The waste hierarchy has to be followed and the best available technologies to be used. In order to prevent the generation of solid extractive waste, that is to use one of or a combination of techniques appropriately selected from pre-sorting and selective handling of extractive materials that in principle qualify as byproducts or products, placing extractive materials that in principle do not qualify as byproducts or products into excavation voids, using extractive materials that in principle qualify as byproducts or products for internal or external purposes. In order to reduce the generation of non-inert extractive waste and hazardous extractive waste, that is to use the following techniques: management of extractive waste accumulation during exploration and prospecting, sorting and selective handling of extractive waste. In order to encourage the reuse and recycle of the solid extractive waste, that is to reprocess of extractive waste. This requires initial characterization of the waste by using international standards. In order to ensure safe disposal and storage, suitable treatment is needed. For example, cyanides destruction before solid waste dumping or piling. Extractive waste is a potential source of valuable materials that are currently not recovered routinely, including critical raw materials. The potential for the recovery from extractive wastes depends on the volumes of the waste and the metals concentration in the waste. Increased recovery from extractive waste reduces the need for active or passive treatment and storage of that waste and the associated environmental impacts. It decreases the need for primary extraction. Extractive waste is usually reprocessed by applying mineral processing techniques. Site rehabilitation is achieved besides recovery of valuable raw materials. Some examples of extractive solid waste handling: recovery and tantalum and niobium from tailings. Tailings deposited in old dams and ponds are reprocessed by means of gravimetric and low-intensity magnetic separation. The following material streams are produced: tantalum and niobium, quartz, mica feldspat, and kaolin, which are valuable industrial minerals, residual extractive waste, which is used for the final rehabilitation of the site. Recovery of critical raw materials and valuable metals from inorganic industrial waste streams. The project focuses on the recovery of chromium, vanadium, niobium, and molybdenum from stainless steel slag, carbon steel slag, and ferrochrome slag without impairing the properties of the residual matrix material for valorization as aggregates and fillers in the construction sector. Improved mineral processing and hydrometallurgical technologies are mainly applied. Biohydrometallurgy, biomining, including bio-leaching and bioxidation, is used in the reprocessing of sulfidic mine waste, where cobalt is produced from old copper mining waste tailings using stirred tank bioleaching technology. Besides cobalt production, the stabilization of those waste and a decrease in the acid rock drainage discharge in the environment are achieved. Bauxite residue as resource in Europe to the right. Bauxite residues are produced as red slurry and contain significant amounts of iron, aluminium, silicon, and titanium oxides, as well as smaller concentrations of critical and industrially important metals such as vanadium, chromium, gallium, rare earth elements, mainly cerium, lanthanum, yttrium, niobium, and scandium. Here results of some of our experiments on extraction of valuable metals from mixed extractive waste are presented. Water is the other issue. In order to prevent or minimize groundwater status deterioration and soil pollution, that is to use one or a combination of techniques appropriately selected from the following list shown here. Application of basal structures and physical barriers, such as impermeable natural soil or artificial basal structures or seepage barriers. Application of water stream management, diversion and water runoff systems, drainage systems for ponds, dams, and heaps, landscaping and geomorphic reclamation, progressive rehabilitation. Application of different coverings, temporary covers, vegetable covers, permanent dry covers, or permanent wet covers. Some other measures for prevention or minimization of groundwater status deterioration and soil pollution are use of special technologies such as permeable reactive barriers for radionuclides, metals or metalloids, and phytotechnologies for metals and metalloids and radionuclides control. Last but not the least, monitoring of emissions to soil and groundwater are needed. Leakage detection system underneath the impermeable basal structure, seepage detection systems, control well. Prevention or minimization of surface water status deterioration can be achieved by prevention or minimization of extractive waste influenced water generation. Reuse of or recycle the excess water in the extraction, mineral processing, or extractive waste management. Measures include installations of thickeners, filter presses, etc. Diversion of water runoff systems during operation. Coverings, different type, temporary, vegetable, permeable, impermeable, etc. Prevention or minimization of emissions to surface water include drained wastewater collection and handling, and collection and off-site treatment of wastewater. Removal of suspended solids or suspended liquid particles are other measures. They can be achieved by gravity separation, clarification, coagulation and flocculation, air flotation, media filtration, membrane filtration for suspended particles, and hydrocycling. Further measures for prevention or minimization of surface water status deterioration include removal of dissolved substances by using oxidation-based systems such as aeration and active chemical oxidation, active aerobic oxidation, aerobic wetlands, use of different reduction-based systems using bacterial activity, application of chemical precipitation and co-precipitation, adsorption, ion exchange, and membrane processes such as nanofiltration and reverse osmosis. Neutralization of wastewater prior to discharge also is needed, which includes active or passive treatments. Last but not the least, again, monitoring of emissions to surface water is required. Monitoring parameters and frequencies are selected according to the site-specific conditions, extractive waste characteristics, and local environmental conditions. Just for completeness, one slide for air pollution and best available techniques that can be applied. Some words for emerging techniques contributing to sustainable mining and mineral processing. They include techniques for improving the extractive waste characteristics, the watering by geotextile tubes that allows the dewatering and containment of slurried extractive waste for mineral processing with high water content. Passivation, microencapsulation and biological treatment. Passivation or microencapsulation of acid-generating extractive waste involves protecting the sulfite surface from water and oxygen. Biological treatment consists of injecting and distributing inoculants and substrates to form a biological film that wraps the material particles. Techniques for preventing and minimization groundwater status deterioration and soil pollution. They include reactive basal structures. The technique consists of adding alkaline materials as neutralizing basal layer underneath the extractive waste to neutralize the seepage and to reduce acid rock drainage generation potential. Accelerated and controlled dissolution of extractive waste. Technique is suitable for waste from mineral processing of potash. Phytomining that uses plants to take up contaminants with the transpiration stream. Techniques for preventing and minimizing surface water status deterioration include removal of dissolved substances by forward osmosis. In forward osmosis, the osmotic pressure itself is the driving force for mass transport instead of using hydraulic pressure. Therefore, compared to nanofiltration and reverse osmosis, forward osmosis does not require significant energy input. Electrocoagulation involves application of an electrical current to coagulate organic constituents and suspended solids in wastewater. This implies electrolysis with graphite or stainless steel cathodes in combination with a metal anode. Use of microbial mats or algae organisms are used to remove metals from mining wastewater. Another measure, removal or destruction of extraction process contaminants, for example, cyanide recycling by membrane and electrowinning technologies, which allow for the recovery of metallic copper and the simultaneous liberation of free cyanide from the copper cyanide complexes, or the extraction of organic pollutants that can be achieved by anodic oxidation. Our experience, a technology for electrochemical recovery of copper arsenic from washing acids. Treatment proposed is based on effluent electrolysis and subsequent processes. Real washing solution from a copper smelting plant in South America was treated with pH initial 0.30.5 and containing arsenic 10 grams per liter, copper 30-40 grams per liter, nickel 1 gram per liter, and sulfides around 2 grams per liter. Solid obtained after the treatment contains 85-92% of copper and about 3% of arsenic. Arsenic is actually eliminated as harmless substances and in a state suitable for further utilization. Heavy metals removal from wastewater through electrochemical treatment. Wastewater from the non-ferrous metallurgy is treated. The method is based on electrolysis, electrocoagulation, electroflotation, precipitation, and co-precipitation processes. Sulfate and molybdenum removal from wastewater through electrochemical treatment. The method is based on electromigration, electroosmosis, electrolysis, and subsequent secondary processes. The concentrations of sulfate and molybdenum were decreased from around 2 grams per liter to 1 gram per liter and from around 2 milligrams to 0.8 milligrams per liter correspondingly. The pH of the treated water was around 8. In conclusion, our society will not be able to continue its development of well-being without sustainable mining and mineral processing activities. This means also strictly observing the hierarchy of extractive solid and liquid waste management, namely pollution prevention at all potential sources on the mine and mineral processing sites, minimization of potential negative impacts on the environment by mitigation measures, reduction of water consumption, reduction of reagents and auxiliary materials consumption, reduction of energy consumption, recovery and beneficial use of water on mine complex, treatment of mine water for beneficial use and as the last option, discharge. Reprocessing of extractive waste. Here, hydrometallurgy is advantageous in this case, since it can be applied at small to medium amounts of waste with low metal content and changing mineralogy at relatively low temperature that require little energy compared to pyrometallurgical processes. The reagents used in the hydrometallurgical processes can be regenerated and recirculated into the circuit of treatment. The hydrometallurgical processes allow obtaining high purity metals that do not require further refining. Thank you for your attention. Yes, it is possible, and we have to do it. Any questions?
Okay, thank you very much, Professor Marinela Panayotova, for your insightful presentation. A point that can be highlighted from Professor Panayotova's presentation is it is very important to implement sustainable mining and mineral processing activities through reducing extractive mining and developing innovations, techniques, and technologies which are more eco-friendly. Some examples related to mineral processing were already mentioned by Professor Panayotova before, such as electrochemical treatment to remove heavy metals from wastewater, such as sulfate and molybdenum. Okay, ladies and gentlemen, hope you are still with us. And next, we will move to the Q&A session. For our Q&A session, there are 4 questions for Professor Panayotova. The questions are, the first one is electrochemical treatment for sulfate and molybdenum in mining wastewater applicable for large-scale use? The second question is, how to treat the sludge from a mining wastewater treatment plant? The third question is, one of the issues in the mining areas is the waste rock that was simply dumped in areas adjacent to the mine, and tailings were typically deposited in valleys or other low areas which serve to contain the slurried waste. Once mining was completed, the operators commonly abandon the sites without conducting any site restoration, except to salvage usable equipment or other materials from the site. The barren piles of waste would be left, posing a long-term threat to water quality through erosion and sedimentation. How to prevent this from happening, and how to manage the disposal site for rock? The fourth question is, how to treat the contaminated groundwater from mining activity? These are the questions for you, Professor Panayotova. Please, your answer now. Thank you.
Thank you for questions. To the first question, is electrochemical treatment for sulfate and molybdenum in mining wastewater applicable for large-scale use? Yes, in my opinion, it is applicable. As far as I know, there are some large-scale applications in Chile where the technology was patented. Actually, in Chile, experiments and implementation started around 20 years ago. Also, in my private opinion, usually around 50% of sulfates that present in water can be relatively easily removed. Recent 4, 5, 6 years, the approach is intensively studied by European scientists, especially in Finland. At large laboratory scale, they achieved a real mine water treatment where the decrease of sulfates was from over 13 grams per liter to the limits for mine water discharge, I mean 250 milligram per liter. However, they combined electrochemical treatment and lime addition. Concerning molybdenum, as far as I know, large-scale studies are carried out again in Chile. The technology is appropriate and private property. Of course, they are usually applied iron electrodes are not suitable, other materials are used. With the electrochemical treatment, one of the main questions is the price of electricity, but I hope this will be solved with the renewables. To the second question, how to treat the sludge from a mining wastewater treatment plant. First of all, we have not to forget that in general case, this sludge contains heavy metals and is classified as hazardous waste. Generally, it has to be allowed to settle. Then solid liquid phase separation has to be carried out by different means, decanting, filtration, and pressure and high pressure filtration. Usually the separated water is recycled in the process, and this is one of the main aims of the mining and mineral processing companies, that this way water is saved. Concerning the solids formed, the next step can be disposing of in proper sites or reprocessing for extracting useful and valuable metals. Very often, these residue contain some high-tech metals in equal or even higher concentration than ores, and it worth recycling. In this case, mainly hydrometallurgical technologies are applied. Concerning the third question, it's a little bit long, but it relates actually to two main issues: abandoned site of mines by operators, and how to manage the disposal site for rock. The first part of the question, yes, abandoned oil mining sites are probably the worldwide problem. My short answer to the question for preventing operators to abandon the sites without conducting any site restoration is to strengthen the legislation at national and international level for multinational companies especially, and its strict observation of the legislation. At least for the cases where new mines are yet to be developed, before the concession is granted, the respective company must deposit in advance funds for restoration, reclamation, and not to forget site post-monitoring. This should be provided by law. Concerning the management of the disposal site for rock, it's site-specific, but at least some easy rules can be followed to avoid mixing of overburden, rock and flotation or hydrometallurgical tailings. Usually the rock is cleaner. To avoid mixing of sulfite and other types of rock, since sulfite rock is the main acid water generator. To decrease as much as possible the contact of sulfidic rock and water and air, and in this way to prevent acid drainage generation. Where possible and available, to mix sulfidic rock and carbonaceous rock. Actually, different measures can be applied depending on the site, as I told. And for the fourth question, how to treat the contaminated groundwater from mining activity? First of all, we have to remember that the main measure for working companies is prevention of polluted water discharge, and measures have to be directed mainly in this direction. Concerning the treatment of already contaminated groundwater from mining activity, there are normal measures for treating groundwater aimed at human consumption or for use for different purposes have to be applied. Treatment technologies depend on the intended use and the polluted water parameters. Usually this water is already neutral and the pollutants can present as cations, but also anion forming elements can migrate with this water, such as selenium and arsenic. Some organic pollutants too. This requires the application of set of treatment technologies, not one, several technologies, for example, precipitation followed by an exchange or adsorption. The precipitation may be preceded by oxidation, for example, arsenic 3 to be oxidized to arsenic 5 that is less soluble and forms insoluble iron arsenates, or reduction, for example, chromium 6 to less water soluble chromium 3 compounds and hydroxides especially. Electrochemical process could also be applied, for example, electrochemically induced coalescence and subsequent electroflotation to remove organic contaminants generally classified as oils. Also, some heavy metals can be removed in this way with this technology. Membrane processes and mostly nanofiltration and reverse osmosis are also applicable. And in conclusion, treatment technologies depend on the intended water use and the polluted water parameters. Thank you.
Thank you very much for your answer, Professor Panayotova. And that concludes our special session today. From the speakers' presentations, we can know that other countries are currently also facing challenges regarding the environmental problems, such as the challenges in waste management in Lagos, Nigeria, the environmental risks that are actually arising from space activities, and also the challenges in mining and mineral processing waste. It is essential to address these problems using the point of view of sustainable development by concerning the sustainability of our environments and also the social and economic aspects. Finally, I would like to send our gratitude to Professor Rotimi Williams Olatunji, Professor Svetlana Drobiasko, and Professor Marinela Panayotova for your time to share your outstanding knowledge and give us more insight about this year's symposium topics. Ladies and gentlemen, thank you very much for your attention. I hope the topics delivered in this special session can give you new insights from other countries. I, Dia Fitria Karini, am saying goodbye for now and will give the time and screen back to Ms. Afifa. Thank you.
Thank you very much, Ms. Fitri. Okay, ladies and gentlemen, this is the end of special session talk. We would like to inform you that we also have a professional talk session right after this. So please click the given link in the live chat box to directly participate in our professional talk session. Once again, thank you for participating in our special talk session of the Second International Symposium of Earth, Energy, Environmental Science and Sustainable Development 2021. This event is organized by Journal of Environmental Science and Sustainable Development, School of Environmental Science, Universitas Indonesia, and supported by PT Riau Andalan Pulp and Paper April Group, Induk Koperasi Kepolisian Negara Republik Indonesia Inkopol, PT Arlindo Grafimedia, PT Unilever Indonesia Terbuka, Bank Rakyat Indonesia, PT Penjaminan Infrastruktur Indonesia, PT Mirar Soputan Mining, PT Merdeka Copper Gold, and Green Era Consulting. We hope that you will learn valuable lessons from today's discussion and create new innovation for global sustainable development. Thank you very much, and I will see you at our next event.